Now that we introduced linear transformations and we went over the definition of kernel, let's go over more interesting examples. Here, I ask you to find the kernel of the following linear transformation. This linear transformation maps the plane into the space. So from 2-dimension to 3-dimension. It takes each vector in the plane and maps it to x minus 2y and 0 and negative y. This is indeed a linear transformation. You need to be able to check that. Now, since it is a linear transformation, let us find the kernel. By definition, the kernel of T is equal to the set of vectors in the very first vector space. It means that in the plane such that this guy maps those vectors into the 0 vector in the space, am I right? So to 0, 0, and 0 in the space. So we need to be able to solve this, am I right? We're looking for all x and y's in the plane such that v of t of x and y, which is by definition is x minus 2y, 0 and negative y, must be equal to 0, 0, and 0 in the space. Very good. So here you have x minus y equals to 0, x minus 2y equal to 0. 0 is basically the same as 0, so we don't have anything to solve here, and negative y is equal to 0. But this guy says, hey, y is 0. If you plug that in, x is 0. So the kernel is basically all x and y's such that x and y is equal to 0. So you have the 0 vector in the plane. The kernel of T has just one member. You can basically denote this guy by bolded 0 here, representing 0 in the plane.